welcome to the last part of Chapter 4. This is part 4 of Chapter 4, and which is the last one, requirements engineering. We will discuss in this part use cases, software requirements, document, validation, checks, change, and management. So mostly it's about requirements, requirements part, or software requirements part. However, we will discuss use cases and we will see what they are. Use cases are actually kind of scenario. Or scenario represented by UML, Unified Modeling Language. And up until now, I'm sure you have already used UML, at least in object-oriented or in algorithm and programming 1 or 2. We used UML for object representation or class representation and the relation between classes and so on. So in here, what we have is exactly the representation of a scenario, and this scenario is representing the interaction between actors and some also the representation of actions. So we have actors and actions done based or from these actors, so we can see the interaction between actors. Actors can be human beings, an individual, a person, or can be a system or a part of a system. A module could be or a function of a system. So we have a set actually of use cases, and use cases usually are applied to each and every function of the system, or sometimes for the system as a whole, to just get an abstract view. Why do we need to have such a representation? It's extremely high level and it's graphical, so what we need from it is a better understanding of the idea. Sometimes we can discuss using this use case with the client or the customer or stakeholders in general. The idea may be clarified using these use cases in a better way, and even for the designers, it may provide a better understanding or a better view of the design or of the functionality design of the system. Now have a look. We discussed the Mentcare system before. So imagine this is a simple actually and plain use case where we have the actors represented by stick figures like this, like a human being, and it's not necessarily that always they are human beings. They can be a system also. A system may impose an action, okay, and these are actions inside the ellipses. These are actions that are taken by the actors. So these are actors, these are actions. So we have these lines that in most cases we have arrows. What does it mean? That means we have the initiative of this action and the direction of the action to be taken. So a medical receptionist, what kind of action can he take or can he accomplish or achieve? Register a patient or view personal info. Well, for medical receptionist, it's not usually the case that this receptionist view records or edit records. No, usually not. This is usually restricted to doctors or nurses. Setting up a consultation usually is done by doctors or maybe permitted nurses based on the doctor's permission. How about managers? Usually they are able to view the personal info, not to register a patient, usually not. Also export statistics, generate reports. Also doctors are all able to generate reports. So this is the idea. We can represent any scenario from our software system based on a use case, and the visualization of the outcome here is extremely simple and easy to grasp, to understand. So that's why we use the use case scenario representation. Before I finish with the use case, we use different types of software packages or applications to implement use case and other actually sequence diagram. Sometimes I forgot to mention it. Sometimes in conjunction with use case, we use also sequence diagrams for further elaboration and showing how events are processed in a system. We have different types of diagrams in UML, and I will create a series of videos about them for practical. Let's just finish this chapter and the next chapter, and within the coming few weeks I'll give series of practical about UML and how we can use Argo UML or maybe Star UML or Visio if you like to create UML block diagrams and system representation where you can even transfer some of the high-level graphical representation to codes, plain codes in different types of programming. We will see how practical these things are, especially if we speak about thousands of use cases or maybe class diagrams. We will see them later on. Okay, software requirements document. We spoke a little bit about the requirements document, and we said that it's an official document needed for as a base for the argument, and it should be approved. So what is this requirement argument? So we said we need to specify the software requirements. That means the user requirements and the system requirements. So we need to write them down in a document which is official. So this document should be an official document so that it should be approved and signed from both parties, the developing company and the client or the stakeholders of the software, or the customers or the client who requested the software to be developed. All right, so what should it include? As I said, definition of the requirements for both user and system requirements, because we actually we know how to distinguish between user and system requirements until now. What we explain about user and system requirements in previous sessions enables us to have this distinguish between the requirements, user requirements and system requirements. Okay, what shouldn't be included in such a requirement is actually initially what the system should provide or should do should be included, but not how the system should provide it. That means we shouldn't suggest anything for implementation, or even the design ideas should be extremely limited. Why? Because this kind of a document is not exactly restricted to, is not exactly provided for design solutions or development solutions. Rather, it is actually listing down all the requirements for the user and the system, so that the developers and the client or the customers agree upon them. Okay, so what the system is supposed to do should be provided there, but not how the system is supposed to do it. Okay, so look at the stakeholders of the requirements document and who actually is going to read them, or these requirements. Now we have a broad actually slice of users or readers of the requirements document. The first one is the system customers. So these customers specify their own requirements, and they should be able they should provide these requirements to the developing company. Then the company should create the requirements in a formal way, as we explained in the previous session, and then the customers should be able to read these requirements and check if they meet their needs or not. So who is responsible about creating the requirements document? Actually, the developing company is not the customers. The customers are needed to validate, to check whether these requirements are the ones they are looking for or not. Okay. Managers should use the requirements document for actually planning for a bid, maybe setting up a proposal or something like that for the system, planning for the budget, planning for the time frame, and so on. System engineers will use the requirements document for designing the system and also for maybe implementing the system. Okay. System tests, or the system test engineers, we have a team of, or we call the testing team. This team is supposed to create some tests for validation, and these tests will be presented based on the requirements document. So we do not get these tests from nowhere. They should have a base. So we will create tests to verify the requirements. Maybe we have for each requirement or set of requirements different tests to be maintained or achieved. And also for the maintenance team, we explained about the maintenance team in first chapter, and we said that we usually have a team that takes care of the software after delivery. That's why we need to maintain some relationship between the system, you can say requirements, and also the interaction between these requirements and the whole system, so that the maintenance team will understand if there is any problem, how they can solve it or how they can fix it, or update if there is any need for it. The requirements validation document, the document variability, we have actually we can have different types of versions of this document format, but the best or the most applicable one or widely used by development company or companies is the IEEE standard. And this is widely used. I will explain about it in a separate video later on. But we have a brief about it in a while. After a few slides, we will have details. Maybe the next slide. Exactly, the next slide. Okay, so we will explain about it. This is a very systematic, you can say, template we use for the software requirements documentation. So the idea here is, well, since we are going to have requirements document, how can we create this template? Well, there are already templates, we can use them, but what to provide inside is extremely important. So we need to detail the whatever the system is supposed to have and produce to us, and the constraints on the system within this document. How do we do it? And now have a look. We have this kind of scenario where we have a preface. So preface is actually suggesting that who is supposed to read this document, and telling about previous versions of the software, if any, if it is not the initial version or the first version, or maybe the history of the updates or whatever the initial version may, or the current version may have over the initial version or versions. Also the reasoning for the software, why the software is developed actually. Okay, so this is the preface. Introduction, we should describe the system, not in details, in just a brief. We should describe the system and what the system is providing. Okay, and the functional and non-functional requirements should also be presented, I mean, in this part. In addition, we need to know, we need to give an idea about how the system is fitting the business plan or the objectives of the organization, or anything related to that. It should be provided in the introduction. We have also a section for the glossary. As I said in previous sessions, that we do not assume usually the customers are extremely familiar with technical terms, so we need to define them in some glossary. Also things related to maybe abbreviations or anything similar to that, we may need to include it. User requirements definition, we explained a lot about user requirements. They should have their own section in the requirements document where we provide the view of the user requirements in details. Functional and non-functional should be provided. And the description should be in natural language, maybe diagrams also, or any other way of, any other graphical way of representation, so that the reader will understand the idea in a better way or a more clear way than just than presenting with the natural language, just a text only. Also, there should be like standards. We should present the standards or the process standards used or followed in the development process, or within the development process, or actually the creation of the document, or during the creation or the writing down this document. System architecture. Now, once the requirements of user requirements are have been listed, then we can move to the system. Well, we don't exactly jump to system requirements directly. No, we need to provide about the architecture actually, which is a high-level view of the anticipated system. So we need to present it in both written and graphical sense. That means we need to show some written text and also some high-level description of modules and how they fit together or how they are distributed over the functional and non-functional requirements. So we need to have some brief about the architecture of the system itself and its components and how they fit and what kind of distributions of the functions over the system available. Then we have the system requirement specification. So once we specify the architecture of the system, then we can explain, or we should explain, describe the functional and non-functional requirements of the system in details. For the user, we usually try to limit the explanation. We do not provide details. For the system, we provide all the needed details, and sometimes we need to add extra, you can say, description for the non-functional requirements. And if there is any interfacing with operational systems around the system that we have, that means the environment, how our system is fitting the environment where it should be provided. Then we have system models. Well, we usually use such graphical representation of the models of the system and how the we display the relationship between system components and the system environment. So it's about interaction. And we see the relation between the system components and also the system and its environment. Sometimes we use object models. As I said, usually we use the UML for such a purpose, for modeling the system. Maybe also data flow models or semantic data models. We will not discuss all those in this introduction course. We will just go for UML to give you a basic idea. In other courses, you will study more on these models. System evolution, as we explained once in, I think, first or second chapter, we mentioned about that first chapter, not second actually. We mentioned that every software is expected to evolve. Why? Due to many reasons. One of them is like the reality itself evolves. The hardware that we use usually evolves. So the environment of the system being developed and used may and for sure actually will evolve. So ultimately we need to have a margin of tolerance with a change later on. So the constraints set on the system, the likely fitting environment, how will it be changed if there is any change in the hardware or the software surrounding the system or fitting around the system. After all these are done, these are the core you can say parts of the requirements document or the structure of the requirements document. We have appendices, and these are related to descriptions of things that we use or we need to have, like maybe the database. We need to give the description of the database that we are using for our system. Maybe the hardware requirements, what kind of RAM there should be for the proper use of the software, maybe a hard disk, the size, maybe the speed of the processor. We should put the minimum and the maximum requirements. That means the minimal and the optimal configurations of the system. Why? Because we are not expecting everybody to use our system with the best performance of a computing system. Some users may not have a very powerful machine, but in that case, you define to them the minimal requirement for proper operational process of the software. Also, we may address data structures, that the structures that we are using, or how the logical organization of our data and the distribution of it, the relationship of the data you can say, repositories with our own software. Index, we may use different indexes in our requirements document. Why? To present maybe figures, lists of figures, maybe lists of functions, tables, so on. So we can provide as many indexes as needed, and they should be provided based on alphabetical index like ABC or whatever. Depends on their alphabetical order. Okay. Requirements validation. So requirements, as we discussed, are extremely important in software development. So this stage is extremely important because it may cut the cost of redoing things too much. In that case, why we need to have a validation process in order for us to check whether or not our system is providing what the user, what the customer, what the stakeholders are requesting or not. So whether it is providing it or not. So whether or not it's providing the correct system outcome or performance in that sense. So, well, why do we need to have this validation? As I explained in once before, that the idea of having requirements document and their validation is because redoing later on after implementation is extremely costly. It takes time and budget, and you need to do like this. It's not just we change or we amend or whatever we do in the requirements that will reflect maybe in a bit of recoding. No, that's not the case. Why? Because the design may change. The dependency may change, and because of the relationship or the dependency between some functions or some components of the system, then we need to redo some part of the system that is related or connected to what we are redoing at the moment or changing. Plus, once we are done with recoding or writing new codes, we need the testing team to test and create new tests based on the change. So that's why it is extremely costly, sometimes goes up to 100 times higher than before doing. So that's why we have the step of validation before we start designing and implementing of the software. Okay, so what kind of checks do we have with the requirements validation? We have checking the validity if our system is providing the functions that best support the stakeholders, let me say, not customers' need. And we explained before that stakeholders may have conflicting requirements and there may be different priorities. That's why the compromise is a must there. So we must compromise these priorities and requirements, and we need to come up with the best fit. Okay, and this is exactly what we discussed with the validity, whether we have the best fit of the functional or the functionality of the system provided to support the stakeholders. Consistency. Do we have any conflict with the requirements being listed in the requirements document? We need to ask ourselves if there is any conflict. We need to fix them before endorsing the final document. And completeness. Do we have all the required functions covered by the document? So all the functions mentioned by the customers are listed in the requirement documents or not? So we need to make sure about all these requirements. They should be listed so that we can call the document complete in this case. Realism. So can we implement and achieve all the requirements? Is it possible to achieve them within the provided time frame and the budget and available technology? If we can do that, then they are realistic. We can achieve them. It's possible. Verifiability. Verifiability is an extremely important step where we have to devise a test-based procedure for checking each and every requirement. Now you may ask me, why do you need to get a test done for each and every requirement, or at least a set of requirements? Because in simple words, as I said earlier, if you do not provide a testable way for requirements, you will get stuck with the customers. Why? They may claim that this is not exactly the requirement that they requested, and they are not quite sure about the outcome of the system based on the provided requirements. But if you provide a verifiable test where you know the input and you have an idea about the output based on some preconditions and postconditions, you can easily convince the customers that we have this requirement and this is the way we test it. If this is agreed upon, then the next steps will be easily achieved, and the conflict between the developing company and the clients or the stakeholders will be much less. So we have the validation techniques. We have different techniques for validation. We have the requirements reviews. It's actually a systematic review and analysis of the requirements where we check the requirements in details, whether they are actually fitting what the clients are asking or not. If there is any mistake, it should be clarified and it should be rewritten where it fits the client or the stakeholders' requirements. And as I said, there should be a compromise there based on the priorities of the stakeholders. Prototyping. We spoke about prototyping also in previous chapters. We said it's an initial version of the software where we do not address everything in detail. So we do not usually have all the details of functional and non-functional requirements. We usually drop all non-functional requirements. We just have a skeleton of the non-functional or functional requirements of the system, so that we discuss this early executable version or model of the system with the stakeholders and see their opinion. This is a way of validation, also technique of validation. Test generation. We may develop our own tests for requirements, as I said earlier, and we maintain some check testability. That means we need to see whether we can test a set of requirements or each and every requirement and generate specific tests that fit them in order to for us to see if there is any certain input and output, how things will be done, or how we can evaluate or assess the validity of these requirements. We spoke a little bit about the reviews, but let me explain further. When we review the requirements, as I said, which is a systematic process where we need to check each and every definition of a requirement, whether it fits its own purpose or not. We need to include stakeholders in the review team. Why? Because they have to confirm whether this review is correct or not. If there is any conflict, should be cleared out, and things should be revised based on the opinion or the instruction of the stakeholders. Okay, so for this specific reason, we need to have good communication between developers and customers. This is extremely important, and it should be at a very early stage of the development so that the cost of redoing will be minimal. What kind of checks for review or reviewing process do we have? Verifiability. We spoke about verifiability, but in brief, if we say any requirement is verifiable, then we are indicating, or we are mentioning, or we are saying that this requirement can be tested, or we can create a realistic test for it. So this is what it means, verifiability. Comprehensibility, that means, do we properly understand each and every requirement? Because we may misunderstand the requirements, and the clarification will be by the communication between the review team and the stakeholders. Traceability is extremely also important as a check for the review. We need to know the origin of the requirement, why this requirement is there, and for what purpose we have it exactly in that queue or in that like line or order. Adaptability, can we change the requirement? Or if we can change it, do we have a big impact on other requirements? So these are all checks for the reviews, and they have to be discussed by the responsible team on the requirements documents finalization. Requirements change. As we said earlier, the change after the requirements are set and the design and implementation are done is extremely costly, and because of that, what we need to do, we need to manage the requirements change in advance before going for design and development. So we lower the possibility of risk of taking extra cost and getting stuck with new requirements change after implementing and maybe delivery. So the requirements change will actually is coming from these three main reasons. The first one is usually business and technical environment, or the environment that holds business and technical parties change. What does it mean? Well, now think about change of a hardware. Think about change of a software. So if the hardware is, we have a new system or maybe a new generation of computing system, then how about the interfacing of our system and the new generation of the hardware? Or how about the maybe software, maybe new operating system or new useful or actually extremely usable operating systems are being developed, so we need to adapt our system to them. So there will be a change, it's a must. Sometimes, apart from technical side, we have the business side. Also, stakeholders may change, their priorities may also change. And this is something that we cannot control. It depends on many factors, including the current situation in business, the priorities of investment, and so on and so forth. So we cannot just force the clients to hold their requirements 100% firm and fit. No, the change must be there. That's why we said this is one of the reasons. The second reason, those who usually pay for the software are not the essential users. What does it mean? Those who request the software as a customer, they provide it to end user other than them. They may use it, but they will not be the essential user of that software. So, well, how can we guarantee that the requirements of those who requested the software, the customers or clients or the stakeholders, will exactly 100% fit the end users? Definitely will not 100% fit. There must be some conflict or some features required later on after delivery, and that's why we need to keep a margin of change in the system. We have also like a large community of users, and these users or stakeholders for sure will have conflicting requirements. So how can we deal with the conflicting requirements? We must deal with it by setting up a compromise. We cannot achieve every conflicting requirements or all the reflecting requirements all together. No, we can't do that. All we need to do is actually create a level of prioritization. That means we set which one should be achieved based on maybe the hierarchy of the stakeholder and which one is more relevant. So we have to balance these conflicting requirements and see which one has the higher priority in order for us to achieve it. Requirements evolution, as I said, requirements evolution is an inevitable action, and usually we have such a scenario where we have an initial understanding of the problem. So we need a software because we need to address a problem or solve a problem. So we can create an initial version of the requirements. Once we have a new or changed understanding of the problem, we need to have changed requirements, and this goes by time. So we may have a number of stages from this kind of scenario. This is possible. That is why we need to have something we call requirements management. We cannot set the requirements change with no management. There should be a process of managing actually the change in requirements. And this is exactly during the requirements setting up and as well as during the development of the software. It's not just during the setting up the requirements only. No, we need also to keep the team while the software is being developed, so that we know, we trace what kind of change is affecting, or this change, what kind of impact will have on our system, and trace all the dependencies on this kind of change request. So, as we said, we need to have a team that manages the requirements, or the need, or the proposed requirements. So before setting the software to use, we need to have a record of the requirements, and whatever change that is done to the requirements, and that will actually lower the cost of redoing things. That will be a record also for test team and maintenance team later on. So how do we do that? We need to keep a track of individual requirements and the links between dependent requirements. So we need to know which requirement is dependent on which, and if we change any requirement, what kind of impact it will provide, or it will impose on our system. And then we need to see and link all these together so that we come up with the firm change proposal. Okay. For this reason, we have exactly the requirements management planning. We do not have the change without any planning. We have exactly requirements management, but in a planned way, which is, you can say, a standardization for requirements management or the change management. So we make decisions based on what? Initially, we need to receive a proposal from the stakeholders about the change, or maybe from the development team, or I'm sorry, either from the development team or from the requirements engineering team, and see if this requirement can be cross-referenced with other requirements or not, and if it is actually valid or not. We need to check. If it is valid, then we need to get into the management process. We need to see what kind of activities we need to do in order for us to apply the change of the requirement. How about the time and the cost, okay, of the change? How about if we assess the overall impact of dependency, because we are not changing a requirement that's totally isolated. It may have a level of dependency that's from like low to high, and that may create a problem. While changing, we need to calculate the time and money cost. Traceability policy, we need to see the relationship between the requirements and see how we can trace and check the knowledge of the system. Every system has its own record of requirements, and we see if we change this requirement, what will happen, what kind of other requirements we need to change based on the impact of this requirement on the overall system and other requirements. So we have also tools to help us in achieving the requirements management. You can think of like spreadsheets. These are just simple tools that we use. There are other very specialized tools. I'll not discuss them in this chapter. Just think back. Developers and software development teams usually use tools to support such requirements management process. We may use also simple database to hold the trace of policies and things related to the change management. This is also possible. So we spoke about the requirements change plan, and this is the change management. We need to check whether the requirements are actually accepted or not based on the following scenario. Since we have a request for change, there is a proposal for a change. We need to check whether this proposal is valid or not. Usually this proposal comes from the stakeholder. So they may propose something which is not possible or valid, which is invalid in brief. So for this reason, we need to validate and see whether this requirement of change is possible or not. We need to analyze the problem and see if the change is possible or valid or not. Then we need to get our reply back to the stakeholders in order for them to make a firm decision either to carry on with the requirement change proposal or to withdraw it. After the problem analysis and change specification, after we confirm, let's say the requirement is valid, we need to move to the change analysis and costing. So we have a problem in the requirements, we need to change it. We have a proposal of change. In order for us to apply the change, we need to see the total effect of the proposed change on the whole system. So we need to assess using the traceability we mentioned earlier. We need to see, we have the knowledge of the system and we have the traceability of which one depends on what, which requirement is dependent and which requirement is independent, and we need to see. So the total cost should be calculated in terms of budget or money or time. And then there should be a decision whether we can proceed with the requirements, with the change requirement or not. Finally, the change implementation. Let's say it is within our frame of time and money. How can we implement it? We need to set the implementation in the requirements document. So we need to change in the requirements document. And the change will be exactly where necessary. What does it mean? Because we said usually the requirements are not isolated, they are dependent. So if we modify one of them, we need to apply the modification to wherever necessary in the document. So in that case, we need to follow a scenario where we create our document easy to be amended or easy to be changed and updated. We can use the concept of modularity. We can create modules so that we know which module will be revised and changed. And also the traceability policy will help us to do so. Okay. This is the process of requirements change management. We have a problem or a proposal for a change, we analyze it and we see the change specification, whether it is valid or invalid, whether it is possible or not possible. If it is possible, we go to the change analysis and costing, we check the cost and the time frame, whether it is acceptable for both the developer and the client or the customer. Then we go for the implementation, and for the implementation we change everything in the every relevant requirements in the software document, and whatever dependency in other requirements should be also revised. Then we will have a revised document for requirements. And this is actually the end of this session. I hope you guys enjoyed it, and I hope you will benefit from it. Until the next chapter, have a good time. Goodbye.